Imagine one of the brightest stars in the night sky suddenly exploding in a supernova as bright as the moon and visible throughout the day. It would be a spectacular event, but what would that signify for Earth and humanity? Could Betelgeuse's detonation trigger cosmic events beyond our imagination? In this exploration, we dive into the phenomenon surrounding the enormous star Betelgeuse and what its eventual explosion could mean for science, the universe, and humanity itself. Experts like the famous physicist Michio Kaku and others have predicted that we might witness one of the most dramatic occurrences in cosmic history during our lifetimes. Betelgeuse, the giant star near the end of its life, is nearing a catastrophic transformation. Once Betelgeuse finally runs out of nuclear fuel, it will undergo a cataclysmic transformation. Betelgeuse is already nearing the end of its stellar life cycle. As it exhausts the hydrogen in its core, it has transitioned to fusing heavier elements like helium, carbon, and eventually oxygen. This process occurs much more rapidly in larger stars like Betelgeuse than in smaller ones like our Sun. When Betelgeuse has burned through these elements, it will no longer be able to sustain the intense pressures required for nuclear fusion. At that point, gravity will take over, leading to a rapid core collapse. This collapse happens in a matter of seconds, compressing the core into an extremely dense and hot state. Simultaneously, the star's outer layers will be blown away in a spectacular supernova explosion. This explosion will be one of the most powerful events in the universe, releasing as much energy in a few seconds as the Sun will release over its entire 10 billion-year lifespan. When Betelgeuse goes supernova, it will likely be one of the brightest events ever observed from Earth. Since Betelgeuse is just 700 light-years away, the explosion could outshine the full moon and remain visible for weeks or months. Some scientists speculate that it could even be visible during the day, illuminating the sky with its fiery glow. After the supernova, the fate of Betelgeuse's core depends on its remaining mass. If the star is massive enough, the collapsed core may form a black hole, an incredibly dense region of space where not even light can escape its gravitational pull. On the other hand, if Betelgeuse is below a certain threshold, it may instead become a neutron star, a compact, superdense remnant of the explosion. In either case, Betelgeuse will be reduced to a fraction of its former self, leaving behind a dense core and scattered remnants across the galaxy. But Betelgeuse's death won't be just a spectacle for stargazers. The explosion will have far-reaching effects. The shock wave from the supernova will send material hurtling through space at incredible speeds, enriching the interstellar medium with heavy elements like iron, calcium, and gold. These elements, forged in the heart of Betelgeuse, critical for the formation of new stars, planets, and even life itself. In this way, Betelgeuse's death will contribute to the cosmic cycle of death and rebirth that shapes the evolution of the universe. Interestingly, Betelgeuse has already shown signs of instability in recent years. It has undergone notable dimming and brightening, raising the possibility that it is approaching a supernova. Scientists are actively studying Betelgeuse, but predicting when the explosion will happen is difficult. It could occur in our lifetime or hundreds of years from now. Nevertheless, Betelgeuse's behavior suggests it is nearing the end of its life. While its explosion would be a spectacular event for observers on Earth, it poses no immediate threat to us. Though supernovae emit high levels of radiation, including dangerous gamma rays, Betelgeuse is far enough away that Earth will remain safe. However, the event would present a once-in-a-lifetime opportunity for astronomers to study a stellar life cycle in extraordinary detail. Betelgeuse's potential supernova has captivated scientists for years, but speculation about the star grew in late 2019 when it experienced rapid and severe dimming. One of the brightest stars in the night sky, Betelgeuse lost around 60% of its brilliance, leading some to believe that the long-awaited explosion was near. As a red supergiant nearing the end of its life, such an event was expected to evoke excitement and fear. Theories about the dimming abound. One suggests that huge dust clouds ejected from Betelgeuse's outer layers may have blocked the star's light. Red supergiants like Betelgeuse often shed material as they approach the end of their life cycles, and these dust clouds may temporarily obscure the star, causing dramatic brightness fluctuations. Another theory suggests that the dimming might reflect internal changes within the star itself. As Betelgeuse's core undergoes increasingly rapid nuclear reactions, shifts in the star's outer layers may cause fluctuations in brightness, signaling that a supernova is imminent. If this theory is correct, it suggests that Betelgeuse is in a more advanced stage of its life than previously thought, inching closer to its final explosive moment. Among those discussing these possibilities is renowned physicist Michio Kaku. He has suggested that Betelgeuse's fluctuating brightness could be the telltale sign of instability, an indication that the star is entering the final stages before its supernova. Kaku points out that recent dimming events, whether caused by dust or internal changes, could be clues that we are witnessing the build-up to one of the most dramatic events in astronomy. So, what exactly is a supernova? A supernova is one of the most violent and energetic events in the universe, marking the dramatic end of a massive star's life. When a star like Betelgeuse runs out of nuclear fuel, it can no longer generate the energy needed to counteract the immense force of its own gravity. The nuclear fusion that once powered the star slows, and eventually, the core cools and collapses. In a matter of seconds, the core compresses into a dense state, triggering a massive explosion that blasts the star's outer layers into space. The explosion is so powerful that for a brief time, the star can shine brighter than an entire galaxy. The shockwave from the supernova sends material into space at thousands of kilometers per second. The star's outer layers, which contain elements forged over millions of years, are scattered across the cosmos. These elements, rich in heavy materials like carbon, oxygen, and iron, spread through space, seeding the interstellar medium. While the destruction of the star is total, supernovae are also creation events. The elements they release are essential for forming planets, moons, and even life itself, including the iron in our blood and the oxygen we breathe. Without supernovae, these essential heavy elements wouldn't exist in large enough quantities to form solar systems and planets. The significance of supernovae extends beyond spreading heavy elements. The shockwaves they generate can compress nearby gas clouds, initiating the formation of new stars. In this way, supernovae contribute to the cosmic cycle of death and rebirth, with the violent end of one star leading to the creation of new stellar formations. The remnants of supernovae, vast clouds of gas and dust, can be observed throughout the universe, slowly coalescing into the building blocks for new star systems. In addition to their role in cosmic creation, supernovae provide a wealth of astronomical data. They act as cosmic lighthouses, illuminating distant corners of the universe and offering insights into galactic structures. The bright burst of a supernova can be seen across immense distances, helping astronomers map the universe and measure vast expanses of space. One of the most common questions surrounding Betelgeuse is whether its supernova could pose a threat to Earth. Fortunately, despite its massive size and energy, the answer is no. Betelgeuse is located around 642 light-years away, far enough that its explosion wouldn't cause direct harm. The intense radiation emitted during the event, including dangerous gamma rays, would be largely absorbed and blocked by Earth's atmosphere, protecting life on the planet from its harmful effects. While Earth would remain unaffected by any harmful radiation, Betelgeuse's supernova would dramatically alter our night sky. The explosion would be so bright that for weeks or even months, it could shine as brightly as the full moon and might even be visible during the daytime. This celestial event would not only be a breathtaking visual phenomenon but also a rare opportunity for both amateur skywatchers and professional astronomers to witness the death of a star firsthand. The sight of such a massive explosion would dominate the skies, captivating people across the globe. The scientific impact of Betelgeuse's supernova would be immense. Astronomers would have the chance to observe a supernova in real time, something that happens rarely with stars so close to Earth. The event would provide scientists with unprecedented data, allowing them to closely monitor every stage of the explosion, from the core collapse to the shockwave that ejects the star's outer layers. Instruments from around the world and even from space would be trained on Betelgeuse, capturing valuable insights into the mechanics of stellar death and the processes that govern the formation of heavy elements. Such an explosion would also give us clues about black holes or neutron stars, which are often formed in the aftermath of a supernova. Depending on the mass of Betelgeuse's core, it could either collapse into a dense neutron star or potentially form a black hole, providing astronomers with another fascinating subject for study. Observing these final stages of a massive star's life will help researchers better understand the life cycle of stars and the role of supernovae in galactic evolution. Michio Kaku, along with other leading astrophysicists, has emphasized that Betelgeuse's recent behavior is generating considerable scientific excitement. Over the last few years, this red supergiant star has displayed signs of instability, most notably during the significant dimming event in late 2019 when Betelgeuse lost around 60% of its brightness. This unusual drop led many scientists to speculate that the star was nearing the end of its life, possibly preparing for a supernova explosion. However, predicting the exact timing of such an event is incredibly difficult. While Koku and other experts have pointed out that these fluctuations in brightness may be warning signs, the nature of these cosmic events means that soon could range from tomorrow to 100,000 years in the future. In cosmic terms, this is merely the blink of an eye, but in human terms, it's a vast stretch of time. The notion of soon must be understood within the context of astronomical scales, where timelines often dwarf the span of human lifetimes. While many hope to witness Betelgeuse's supernova within our lifetimes, the star could continue to exhibit erratic behavior for centuries before it finally reaches the end of its life cycle. The dimming in 2019 inspired a number of speculations. Some scholars believe it was generated by dust clouds formed from debris ejected by the star, which temporarily obscured its light. Others believe it could be an indication of internal changes in the star as it enters the final chaotic stages of its existence. Whatever the cause, Betelgeuse has drawn a lot of attention due to its extreme brightness fluctuations. As a result, scientists are on high alert. Telescopes from all over the world, including NASA's Hubble Space Telescope and the recently launched James Webb Space Telescope, are carefully monitoring Betelgeuse. These instruments are primed to detect any additional anomalies in the star's behavior that might provide further clues as to when a supernova could occur. The hope is that these observations will capture the prelude to a supernova event, giving scientists an unprecedented opportunity to study a massive star's final moments in real time. In addition to these telescopes, astronomers are using ground-based instruments to monitor changes in Betelgeuse's light curves and spectral emissions. Every new data point is being analyzed to identify any signs of core collapse, the process that signals the star is about to explode. The anticipation surrounding Betelgeuse's eventual supernova is immense, as it would be one of the most thoroughly studied celestial events in modern history. When a star like Betelgeuse reaches the end of its life, its core undergoes a profound transformation. As fusion reactions in the star's outer layers begin to exhaust lighter elements like hydrogen and helium, heavier elements such as carbon, oxygen, and ultimately iron start to dominate the core. This marks a pivotal moment in the star's life cycle because iron is unique. Unlike lighter elements, it cannot undergo fusion to release energy. Fusion reactions of lighter elements create outward pressure that balances the star's immense gravitational pull, but with iron, no such energy is produced. Without this outward pressure, the star's core becomes unstable and succumbs to gravitational collapse. This collapse is a dramatic event that occurs in just a matter of seconds. As the core contracts, its density and temperature increase to unimaginable extremes. When the core reaches critical mass, the material becomes so densely packed that it triggers a rebound effect. In this moment, the core compresses to such a degree that the atomic nuclei can no longer sustain the gravitational pressure, causing a shockwave to surge outward. This shockwave rips through the star's outer layers, propelling vast amounts of stellar material into space at incredible speeds. The energy released during this process is mind-boggling. In the span of a few seconds, the supernova emits as much energy as the Sun will radiate over its entire 10 billion-year lifespan. This immense burst of energy includes light, X-rays, gamma rays, and even neutrinos, particles that rarely interact with matter but are produced in colossal quantities during the explosion. Supernovae are not only breathtakingly destructive natural phenomena, but they are also essential to the continuous process of cosmic evolution. Heavy elements, including carbon, oxygen, silicon, and iron, are carried in the material that is expelled from a supernova. These elements, formed during the star's lifespan and under the intense explosion conditions, enrich the vast regions of space between stars, known as the interstellar medium. These components are necessary for the emergence of new planets, stars, and even life itself. The universe wouldn't have the chemical diversity needed to produce the intricate structures we see around us if supernovae hadn't contributed to it. Betelgeuse, as a red supergiant, is nearing the point where this process may unfold. While it's uncertain when exactly the explosion will occur, when it does, it will unleash this incredible cosmic recycling process on a massive scale. The remnants of the star will seed the universe with the building blocks for future generations of stellar systems. In the meantime, scientists closely monitor Betelgeuse for signs that this gravitational collapse might be imminent. Instruments like NASA's James Webb Space Telescope and ground-based observatories are trained on the star, seeking any further signs of instability or change. The explosion, when it happens, will not only offer a spectacular display for skywatchers but also provide a rare opportunity for astronomers to study the life cycle of massive stars and witness firsthand the violent birth of new elements scattered across the universe. Betelgeuse's eventual supernova would be more than just a spectacular sight for Earth's observers, it would also have profound implications for the cosmic neighborhood. When massive stars like Betelgeuse explode, they send out powerful shockwaves that propagate through the surrounding space. These shockwaves, laden with energy, have the ability to compress nearby clouds of gas and dust, which are the fundamental ingredients of star formation. The compression of gas clouds can act as a trigger, sparking their collapse and initiating the process that leads to the birth of new stars and planetary systems. If Betelgeuse goes supernova, its explosion could have a significant impact on its surroundings, potentially leading to the formation of new stars in the Orion constellation. This event would be part of the grand cosmic cycle, where the death of one star provides the essential materials and conditions for the birth of others. The heavy elements forged in the core of Betelgeuse, such as iron, carbon, and oxygen, would be expelled into space, enriching the interstellar medium and providing the building blocks for future planetary systems. The supernova would not only contribute to this cosmic cycle but also release intense radiation across the electromagnetic spectrum, from visible light to X-rays and gamma rays. This radiation could interact with nearby stars and systems, further influencing the dynamics of the region. Astronomers are particularly excited about the possibility of studying such an event in real time, as it would offer invaluable insights into the processes of star death and rebirth. It would also provide a rare opportunity to observe how supernova remnants interact with the surrounding environment, shaping the evolution of the local galaxy. Supernovae play a crucial role in cosmic history and the future by helping us understand how the universe's chemical composition has evolved over time. These powerful stellar explosions are responsible for synthesizing heavy elements essential for planet formation and the organic molecules necessary for life. Elements such as carbon, oxygen, iron, and nitrogen, the building blocks of life as we know it, are forged in the intense environments of supernovae. Without these cosmic events, the universe would be predominantly composed of hydrogen and helium, rendering it a barren place with limited potential for the complexity required for life. When Betelgeuse eventually goes supernova, it will present an extraordinary opportunity to study the aftermath of such an explosion up close. The remnants of supernovae, known as supernova remnants, are incredibly valuable to astronomers and physicists alike. They provide critical insights into various phenomena, including the formation of neutron stars or black holes and the distribution of heavy elements across the galaxy. These remnants consist of expanding clouds of gas and dust that spread out the products of the explosion, contributing to the cosmic material that will eventually form new stars and planets. One possible outcome of Betelgeuse's death is the formation of a neutron star. This incredibly dense remnant, typically about the size of a city but containing more mass than the Sun, would create an extreme gravitational field. Neutron stars are fascinating objects that offer unique opportunities to study matter under extreme conditions, shedding light on the fundamental physics that govern stellar evolution. Alternatively, if the remaining core after the supernova is sufficiently massive, it could collapse into a black hole. This process occurs when the gravitational pull is so strong that not even light can escape, resulting in a region of space where the laws of physics, as we currently understand them, break down. The formation of a black hole from Betelgeuse's remnants would add another layer of intrigue to the study of stellar death. The impending explosion of Betelgeuse could also help answer critical questions about the life cycle of stars, the mechanics of stellar explosions, and the evolution of galaxies. Observations of Betelgeuse's supernova would allow scientists to gather data on the light curves and spectra emitted during and after the explosion, offering clues about the energy released and the specific elements created during the event. The scientific implications of Betelgeuse's supernova would be enormous, presenting a unique opportunity for astronomers and physicists to study one of the universe's most violent events in real time. This explosion would serve as a living laboratory for observing how supernovae evolve, providing insights into processes that are usually difficult to observe. As Betelgeuse undergoes its final transformations, scientists would be able to monitor its behavior closely, enabling a comprehensive analysis of the mechanics of stellar death. One key aspect of studying Betelgeuse's supernova is the potential for detecting gravitational waves. Modern observatories, such as LIGO, Laser Interferometer Gravitational Wave Observatory, are equipped to detect these ripples in spacetime caused by the acceleration of massive objects. The explosion of Betelgeuse would generate significant gravitational waves, offering critical data about the dynamics of the explosion and the interaction of mass and energy during the event. This could enhance our understanding of the nature of gravity itself and the fundamental laws governing the universe. Additionally, the detection of neutrinos, tiny, nearly massless particles produced in vast quantities during a supernova, would provide yet another layer of data. Neutrinos can escape the dense core of the star almost without interacting with matter, offering direct information about the conditions inside the collapsing star. Observing these neutrinos could provide essential insights into the core collapse process, including the temperature, density, and composition of the material before and during the explosion. Moreover, Betelgeuse's supernova has the potential to redefine multi-messenger astronomy. This innovative approach involves collecting data from various types of cosmic signals, such as light, gravitational waves, and neutrinos, to create a more complete understanding of astrophysical phenomena. By combining these different types of information, astronomers can piece together a fuller picture of the supernova event, revealing how these different signals correlate and what they tell us about the processes occurring within Betelgeuse. This multi-messenger approach could lead to groundbreaking discoveries, enabling scientists to connect the dots between different cosmic events and improve our understanding of stellar evolution and the life cycle of galaxies. Furthermore, it could help establish a new framework for studying other astronomical events, such as gamma-ray bursts or black hole mergers, thereby expanding the boundaries of astrophysical research. Throughout history, supernovae have had a tremendous impact on human culture and philosophy, providing spectacular reminders of the universe's vastness and our precarious existence within it. Ancient civilizations, from the Babylonians to the Chinese, interpreted these celestial events as omens or divine signals, often associating them with significant earthly occurrences, such as wars, plagues, or the rise and fall of rulers. For example, the supernova of 1054 was recorded by Chinese astronomers and is believed to correspond to the creation of the Crab Nebula, which still fascinates astronomers today. These historical interpretations reflect a deep human instinct to find meaning in the chaotic and often unpredictable events of the cosmos. As we gaze toward the heavens today, we find ourselves contemplating the eventual explosion of Betelgeuse, one of the most prominent stars in our night sky. The potential supernova of Betelgeuse presents a unique opportunity to connect ancient beliefs with modern scientific understanding. Could this event spark a cultural moment akin to those experienced by our ancestors? As scientists monitor Betelgeuse's fluctuations in brightness and prepare for a spectacle that could rival the brightness of the moon, we may find ourselves reflecting on the deeper implications of such a cosmic event. Betelgeuse's supernova could serve as a powerful symbol of the impermanence of existence, reminding us that stars, much like ourselves, have life cycles characterized by birth, evolution, and eventual destruction. This stellar event could evoke discussions about the nature of life, the interconnectedness of the cosmos, and our place within it. As we ponder the grand cycles of creation and destruction that govern the universe, Betelgeuse's explosion may inspire a renewed appreciation for the delicate balance of life on Earth and the universal forces that shape our reality. Betelgeuse's possible supernova is a powerful reminder of the universe's incredible power. This red supergiant, located approximately 642 light-years away, could explode at any moment, be it tomorrow or in 100,000 years. Its imminent explosion captivates scientists and skywatchers alike as it symbolizes the mysteries that continue to intrigue humanity. When Betelgeuse does eventually go supernova, it will not only be a dazzling spectacle but also mark a significant event in cosmic history. This explosion could outshine entire galaxies, offering a unique opportunity for astronomers to study the intricate processes of stellar death and rebirth. It stands as a beacon, illuminating our understanding of the universe and the life cycles of stars. As we await this magnificent event, we are reminded of our place in the universe and the ever-evolving story of cosmic creation. The exploration of Betelgeuse and its future will undoubtedly inspire new generations of scientists and enthusiasts alike. If you found this exploration of Betelgeuse fascinating, don't forget to like, share, and subscribe for more journeys into the wonders of the universe. Until next time, keep looking up.